All right, now we're ready to look at the power rule for exponents. So looking at our table, first row says 3 to the second to the second. So that means I have 2 of what's in parentheses. I have 2 of these 3 to the seconds. Or there's 3 to the fourth, because remember our multiplication rule said we keep the base and add our exponents. Second row says 3 to the fifth raised to the third power. So I have 3 to the fifths. Again, add up your exponents, we get 3 to the 15th. Next row, 3 to the ninth to the fourth. So I have 4 of these 3 to the ninth. So I have 3 to the ninth times 3 to the ninth times 3 to the ninth times 3 to the ninth. Keep your base, add your exponents. And finally, 3 to the sixth to the fifth. So I have 5 3 to the sixes. Keep your base, add your exponents. Maybe you're starting to see the pattern. So the rule for raising a power to a power says a to the m to the n is equal to a to the m times n. So when we have a power raised to a power, we are going to multiply the exponents. So looking at the examples down below, 7 to the fifth raised to the eighth power. Take 5 times 8, you get 7 to the 40th. X to negative 3 raised to the negative second power. Take negative 3 times 2, we get x to the 6th. All right, let's look at some examples together. So simplifying a power raised to a power. And we said the shortcut is to just multiply our exponents. So 5 times 3 is 15. I get x to the 15th. In number 2, I'll have y to the negative 54th. Remember, cannot leave a negative exponent in our final answer. So rewrite it as 1 over y to the 54th. Number 3, 4 times 6 is 24. So we get a to the 24th. And finally, number 4, negative 4 times negative 2 is 8. So we have b to the 8th. Raising a product to a power says that a to the m times b to the n, all raised to the p power, equals a to the m times p times b to the n times p. So that means the exponent outside, so in this case the p, gets distributed to everything inside. So let's look at some examples. In number 5, I have 3x to the fourth, all raised to the third power. Remember, the 3 inside parentheses has an exponent of 1. So I'm going to distribute my exponent of 3 to both of them. And remember, the shortcut is to multiply. So if I have 3 and I do 1 times 3 is 3. And then for x, I take 4 times 3 is 12, which is 27x to the 12th. Same idea, number 6. So this 5 has an exponent of 1. So if I multiply exponents, I have 1 times 2 is 2. And on the y, 9 times 2 is 18. So we get 25y to the 18th. And number 7, so this 2 has an exponent of 1. I'll get negative 2 to the 5th, a to the 30th. And I'm just going to leave that one like that. And in number 8, again, the 4 has a 1, so a 4 to the negative 2, b to the positive 10. Let's rewrite this so we have positive exponents in our final answer. And I can simplify 4 squared to 16. All right, now let's put it all together. In number 9, we have x to the 6th times x squared to the 9th. So let's do order operations and clear parentheses first. So we have x to the 6th times x to the 18th. We're going to multiply those two powers. And now we have multiplication property, which tells us to add our exponents, and I will get x to the 24th. Number 10, again, clearing parentheses first. So we'll have n to the negative 5th times n to the negative 12th. Add your exponents, you get n to the negative 17th. However, we cannot leave a negative in our final answer, so we rewrite it as 1 over n to the positive 17th. And 11, so we have two sets of parentheses with powers on each. So we'll have 7 squared, x to the 12th, times x to the 18th. 7 squared is 49. And then on the x's, add your exponents, and you get x to the 30th. And finally, number 12. Clearing parentheses, we have n to the negative 15th times 2 to the 4th, n to the negative 12th. 2 to the 4th is 16. And then add your exponents on the ends. We get n to negative 27. Can't leave a negative exponent in our final answer, so let's rewrite this as 16 over n to the positive 27th. Okay, now go ahead and try the Power Rule for Exponents practice worksheet.